Hi there, we're Team 1028S Mandroid's OopsAllBerries, and this video is for the Create US Open. We are an all-senior team. I'm Jackson Henry, and I am the head engineer for this robot.
I'm Brett. I'm the team programmer and driver.
I'm Tammy. I'm in charge of the logbook, but we all contribute.
I'm Lauren. I'm the primary alliance maker and website designer for the team.
I'm Shane, and I help engineer the robot and create a 3D CAD of the robot.
Being seniors, we've learned over 4 years that the autonomous period in the competitions is critically important because it's the first tiebreaker as well this year in this game. So this year we're using an array of sensors to create an accurate and reliable autonomous that will win matches for us. So we have a couple potentiometers, one that measures the position of the arms here, and then another one up in the front that measures the position of the hands. And we also have on the back of each motor an integrated motor encoder. It's the little black box on the motor that measures the rotations of the wheels. Potentiometer measures the position of the axle for the arms against the metal. So using this, we can get the readout of our sensor values and can diagnose and construct really accurate autonomouses that win matches really reliably. And also we can do skills as well. So this year we've been putting a lot of time and effort into creating autonomouses.
One of the biggest strengths of our robot is in the speed and strength of the lift itself. On the sides here it has 3 motors for either arm. They're all speed motors here, and so that allows for a very quick and very strong lift. It can lift up to like a cube and a star, or up to like 4 or 5 stars all at once. And with the help of these rubber bands here, it's able to throw them onto the other side into the far zone, which of course is worth more points. And then of course down here in the hands, it's got 2 motors running the hands with the sort of claw grip that comes around and picks up stars and cubes in this area down here. And these are both geared together so they don't ever separate, they stay together at all times. And the robot itself is on a H drive with 4 motors on the chassis, and these motors are geared to, they're chained together to prevent them from browning out.
So over the year, we had tipping issues with our robot, and so to fix that, we added these linear slides in the back here to help keep the robot from tipping. Well, also in the front, we added this linear fork to help pick up cubes and to help when we grab the cube to stop their motors from grabbing us hard and browning out.
So for community service this year, our school decided to set up a robotics camp for elementary and middle school students. Our team, as well as our other schools' teams, helped volunteer to teach these students how to build simple robotic structures, and we also hosted a mock competition at the end of the 2-week period for them. Also, our school decided to go down to the science fair when we were hosting it, and then as parents and kids walked by, we showed them how to drive and how robotics works. So we hope that these kids enjoy robotics as much as we do, and hope that they come back in high school.
Alright, now we're going to display some of the robot in action here on the field with Brett, our driver. Now, the robot, as you can see, it moves around and grabs stars in the claws there, and then comes over to the wall and dumps them over to the other side. See, they went into the far zone over there. Now Brett's going to go for a cube. As you can see, he easily picks up the star and the cube at once and tosses them into the far zone. The anti-tip system really helps with preventing it from tipping over at any time when it's jumping. And the robot itself just doesn't brown out because of the weight distribution we have on the motors to prevent that sort of thing from happening.
Okay, so this is our team logbook. We start with the table of contents, and that has the about the game, the brainstorming, building, programming, competition, and the CAD. We start at the game manual and the object of the game and our goal for accomplishing. This is the team bios with the grades, positions, and the goals that we have this year. We start with the building process with the timeline that goes from the beginning when we brainstorm to the end. we have different. We had a design matrices everywhere to score which robot we thought would be the best. And at first it was the catapult robot, but in the end we decided to go with the parallel arms. At we made notes to communicate through the logbook to each other, and we noted changes whenever there was any. We have a programming page with examples of code and goals, also different autonomouses that we have.
Also, we've created AutoCAD 3D CAD as a robot using the Vex library and Autodesk Inventor. So these are a few of the pictures that we have, but we are also continuing to work on AutoCAD now up until the tournament.
Thank you
So
very much.
thank you very much.